In this second video, we will learn how to take the data and assemble a histogram, which will allow us to look at the distribution of the data. So for this data set, I'm going to take our height in centimeters and use that for further analysis. So I'm just copying and pasting it into a new spreadsheet, and I'll minimize it so that we can see all the data on one screen as well. Just like we learned in the last video, I'm going to start by sorting the data from low to high. Note this time it did not have a pop-up window because there was no adjacent data to the left or right of the height in centimeters. Now that my data is arranged from low to high, just as a way of bookkeeping, I'm going to place a 1 next to each value. A histogram is a bar graph that tells us about the distribution of the data. And so looking at this data and having computed the averages on the previous sheet, we would expect that most students fall within a range close to the average, with several outliers at the short and tall end of the spectrum. And so we'll construct our data into a graph and see if that is correct. So for a histogram, one of the first things that we have to do is create bins. And so the bins that we're going to use are going to be from 150 up to, but not including 160. And so if you notice here, I'm using a special kind of notation known as interval notation. These are commonly used when expressing inequalities. What this is saying, this bracket, square bracket here is saying, including the number 150 and above, and all numbers up to but not including 160 will fall in this bin or tub where we can place the data. So we're going to make bins from 160 up to but not including 170, from 170 up to but not including 180, up to but not including 190, and finally from 190 up to but not including 195. And so our min and max data, 156 and 190, will all fit within these bins. So next what I'm going to do is I'm going to put an equal sign and write the word sum, which adds up that series of values. So I'm going to open a parenthesis, and I'm going to sum all the data points that fall between 150 and 160. So you can see here that there are only 2 data points that fit into those categories. So I'm going to close the parentheses and hit enter. And I'm going to repeat that for each step. So from 160 up to, but not including 170, since we have a parenthesis on that side. Oh, so you can see here that it just was equaling this because I have the wrong formula. I actually want this to be equal sum. That looks better. Same thing here, equals sum. We're going to include 170 this time. We're going to go all the way up to, but not include 180. Next is from 180 up to, but not including 190. And finally, we only have one student that fits into that top bin. So now I can plot this data in a histogram. So this is the number of students that fall into each of those bins. And I can double check to make sure I haven't lost any data by summing up this column. If we started with 35 data points, we should end with 35 data points, and that's what you see here. So this part of our data analysis looks correct. To plot this, I'm going to select the data, go to Insert, and I'm going to click the vertical bar graphs here. And so at first glance, our chart looks how we may have predicted. Most students have an average height, tapers off as we get to the extremes, and then we have few students that have very short stature, and one or two students who have large stature or are tall. And so while this graph qualitatively looks correct, it's missing all the components such that we can analyze it correctly. So one thing that I'm going to do to start is you can see that my x-axis here has values of 1, 2, 3, 4, and 5, which are meaningless unless I were to label these bins as bin 1, bin 2, bin 3, bin 4, bin 5, and then I would have some sort of key associated with it. What would be more useful is if I click on the graph somewhere and then right-click, I can pull up this window that says Select Data. Once this window is up, I can edit what those labels say. So instead of being 1 through 5, if I hit Edit, this window pops open and I can give it an axis label range. But by selecting this blue button here, it'll send me back to the spreadsheet, and now I can say that I want these to be my labels. Once those are highlighted here, I can click this button again, hit OK, and now you can see that our table shows our bins by size. There's a few other things that we should change on this graph to make it more useful and to make it visually more appealing. So for starters, as of right now, it is pretty hard, even if I expand the graph, to read the fonts. So if I right-click on the axes, if I left-click on the axes and then right-click, I can change the font parameters here, or I can change them up here. So I can make these larger. Let's say 20 looks visible. I can bold them. Default color from Microsoft Excel is gray, which sometimes when you copy and paste it into a PowerPoint presentation or a Word document looks washed out. So we can change this back to black. I can do the same thing on the y-axis. I can increase this to the same font size, bold it, and color it black as well. My chart title should be larger and more visible. Now I'm going to change that in the color as well. And then we should give this a title that represents what the data shows. In this case, let's say student height. These numbers across the left, while we may know what they mean from the context of this video, if we were to hand this to someone, they may not know how to interpret the data. So all good charts or graphs should be interpretable without any other information. So you should be able to hand it to a teacher or another student, and a week or more later, they should be able to look at the graph and understand exactly what the graph is trying to convey without a figure legend or having someone explain it to them. And so these are essentially unit lists right now. So if I click on the graph, I can come up here to the Design or Format tab. I'm going to click the Design right now, and I'm going to add Chart Element, Axis Title. I'm going to put a vertical title on, and I'm going to add a second element, Axis Title, Horizontal Axis. Down here, we can change this to something appropriate, like students, height, bind. That's pretty small, so we can increase the size of that so it's visible. And over here, this histogram is showing a distribution of data, so this is the number of students. So now I feel that this graph has all of the information necessary for it to be interpreted by anyone you may hand it to. I can come here and I can say there are 2 students who have a height between 150 and 160. Actually, I can think of one more thing we should add to this graph before we continue. the units, which in this case are centimeters. Now, there's a few other things we can do to the graph to make it look nicer and more presentable for publications, Word documents, presentations. Typically, we're used to seeing graphs that have a strong X and Y axes. And if that's what you would want to do for this data set, we could do that as well by clicking on the axes with our left mouse, right-clicking, go to Format Axis. This window will pop open on the right. If we click on the paint bucket, we can make modifications to the line. We want a solid line. Let's say we want to make it black. And then we can increase the width to make it heavier. Let's set it at 4, and then we can do the same thing for the x-axis. Change the color to black, increase the width to 4. And that looks quite nice. If you're interested in making artistic adjustments like the color, you can always select your data. Once you have the paint bucket selected, you can click solid line. You can change the data. In this case, I'll change the border to red. And then I will also change the fill to the same red color. And finally, if you wanted to adjust the width of the data points themselves, you can click on the histogram looking icon here, and over gap width, you can minimize the gap width so that the data points are wider and more close to one another. And if you had multiple series of datas, so let's say height in inches and height in centimeter, you could overlap them or stack them on top of one another using this function right here. So now this graph looks nice. It displays all of the appropriate data. It's easily interpretable, and it can be copy and pasted into a Word doc or a PowerPoint document. To do that, select the graph. You can hit Control-C, which will copy, or you can right-click and select Copy from the menu. Once copied, you can open up a Word document or a PowerPoint presentation. In this case, I've grabbed the syllabus for our Honors Algebra 2 class, and you can paste by either right-clicking or hitting Control-V. And so you can see now we have our graph. If I click on it, I can resize it. But you can see that because Microsoft Office and Microsoft Word, because Microsoft Office contains both Microsoft Word and Microsoft Excel, you still have the ability to edit things within Microsoft Word, which, as you can tell, for formatting sometimes causes errors. So I'm going to hit Control-Z to resize it to the original, Control-Z again to undo the paste. Sometimes it is more appropriate to come up here to the paste and paste special as an image. In this case, let's use a JPEG. Now if I scroll down and find it, you can see here's the figure. By clicking on it, I can no longer make edits. But when I make the image smaller, it maintains all of its formatting. So as you can tell right now, it is treating the image as if it is just another letter or piece of font. And because of that, it is messing up the format of the paragraphs. So one thing we can do is we can right-click on the image and go to Text Wrap. We can change this to square or tight. And that'll allow us to insert it where we want in the document. So let's say that this figure went with information in this paragraph right here. We can set it right there. Because it's square, it gives us a nice justified border around it. And it ends up looking very nice within our document. Thank you.